Hi, my name is Cem Keskin. I'm a postdoc researcher at Microsoft Research Cambridge, and I'm mainly working on computer vision and its applications, mostly in interaction scenarios. Today I'm going to demonstrate our application which does hand state recognition using Kinect. As you know, Kinect has revolutionized the way we do gaming or we use applications, but still it wasn't exactly suitable for certain user interaction scenarios. For instance, when you wanted to push a button or select items. That was mainly because what Kinect currently does is it tracks your body, it tracks your joints, and it tracks your hand as a single point only, and it's mainly agnostic to what your hand state is, so it doesn't really know whether your hand is open or closed, so you cannot use very intuitive and natural gestures such as opening and closing your hands for interaction. So what we did was we used the same machine learning methods that were developed here to do body pose estimation to the problem of hand gesture recognition. And by doing this, we basically extended the Kinect algorithms to also cover hand state recognition. Here I'd like to demonstrate what we're basically doing. This is our main demo app, and as you see down there in the bottom window, the skeleton there, it gives you where my joint locations are, and it's the basic output of Kinect. It used to be the basic output of the Kinect before we started this project. So now we extended this by introducing a new machine learning algorithm that is based on big data to recognize hand gestures. For instance, if you look at my hands, those are automatically localized and painted either blue or red. So this is actually a machine learning method, an AI method, let's say, which maps each of the pixels into either a body part, as you see green here, or blue for an open hand, or red for a closed hand. So by looking at the majority of the pixels and analyzing the output of this machine learning method, we can determine whether our hand is closed or open. As you see, when my hand is open, it's not tracked, for instance, for this scenario, and when I close my hand, it's being tracked, and it's quite precise. So by keeping track of the hand states and the hand state changes, I can basically make the application track my hand when my hand is closed, and that can be used to, for instance, draw, and in this, as you see in this simplistic case, and it's quite precise. Or actually you can use this idea to drive Windows 8 applications, which are already mostly touch enabled. Here I'm going to demonstrate a few examples. For instance, here you see the Bing Maps application. We haven't touched the code or anything, of course. This is fresh out of the store, and you can interact with the map by using your hand states. For instance, here we basically imitate what we do with touch-enabled surfaces. So if you close a single hand, it's single touch. You can pan the map, and if you're using both of your hands, it basically acts like touching on the surface with both of your fingers. So you can do pinch to zoom or unzoom, and it's quite natural. So this is very useful for living room scenarios, kiosk scenarios, or where the Kinect is being now used, like store scenarios, basically, so that you can interact with different applications. So we developed this new technology with the Kinect for Windows team. They collected hundreds of videos from actual people interacting with similar scenarios, and they manually labeled the data so that we can use it in our machine learning setup. And by doing this, actually, we made the system quite robust to changes and variation in hand shapes, different types of hand, different people, for instance, size of people, gender of people, different clothes, long sleeves, baggy clothes, for instance. So it's quite robust and it's extremely fast too. So this method has been released as part of the Kinect SDK last March and is now available to use for other developers in their own scenarios and applications. Thank you.